The universe. Vast, empty, and as far as we know, lifeless. With one exception. Earth. Why? What is it that makes our planet so special? The answers are hidden deep in the Earth's past. To find them, we must travel back in time to see for ourselves the first humans walk the Earth, ride continents on a collision course, face killer dinosaurs, dive into oceans full of bizarre life forms, feel the bitter chill of global ice ages, and experience the fury of cosmic missile attacks, until we reach the very beginning to witness the birth of the Earth itself. Then we can piece together our planet's incredible story and discover why all of this, all of us, are here. We've arrived. Almost 5 billion years ago. This can't be right. There's no sign of our beautiful blue planet. Just a newborn star, our sun, surrounded by all this dust. We've arrived too early, before the Earth has even formed. Somehow, out of this chaos, our planet will emerge. Speed up time, and we can see gravity pulling the dust into tiny rocks. It hardly seems possible that something as complex as a planet is made from nothing more than rocks, dust, and gravity. Over millions of years, these rocks are forming a planet. This is it. The Earth, 4.54 billion years ago. But it looks more like hell than home. Up close, the temperature is over 1,200 degrees Celsius. There's no air to breathe, just choking carbon dioxide, nitrogen, and water vapor. So hot, so toxic. Get any closer and we'd be incinerated and suffocated in seconds. The newborn planet is a boiling ball of liquid rock. There are virtually no solid surfaces, just an endless ocean of lava. And the Earth is still being bombarded. It's a young planet, the size of Mars, and it's heading straight for us. It's traveling at nearly 15 kilometers a second, 20 times faster than a bullet. It's looming over us like a vast alien spacecraft. The intruder's gravity is distorting the Earth's surface. The blast wave is racing out around the planet. It's as though both young planets are turning to liquid. Trillions of tons of debris are blasting out into space. But over the course of just 1,000 years, gravity works its magic, turning rubble into a ring of red-hot dust and rocks circling the Earth. And now, from this ring, a 3,500-kilometer wide ball is forming. We're watching the birth of our moon. It's much closer than the moon we recognize, just 22,500 kilometers away, instead of over 400,000 kilometers. The sun's rising over a cooling Earth. But this is strange. It's setting just 3 hours after it rose. The impact must have set the Earth spinning so fast that an entire day lasts just 6 hours. The Earth may be turning fast, but it's changing slowly. To understand the making of our planet, we need to fast forward through millions of years. A hail of meteors. $3.9 billion years ago, and we're under attack from debris left over from the solar system's formation. Look inside at these strange crystals. They look like grains of salt, the same salt you'd put on your fries. And inside these, minute droplets of water. It seems these deadly missiles could contain the vital ingredient for life on Earth. There's only a small amount of water inside each meteorite. But as they bombard the Earth for over 20 million years, pools of water grow. The water collects on solid ground. The Earth's core remains molten, but its surface has cooled to around 70 or 80 degrees Celsius, just enough to form a crust. In the future, we could swallow this water when we take a drink. Every sip, every puddle, every drop of water in every ocean is billions of years old. And it's traveled millions of kilometers to reach us, carried inside a meteor. The Earth looks more familiar, but this is still a dangerous place. This wind is fast, perhaps faster than the most destructive hurricane. We're caught in a megastorm, whipped up by the planet's rapid rotation. The moon is so close to Earth, its gravity is overwhelming. It's creating these huge tides racing across the planet's surface. But over time, the moon moves away, the waves calm, and the planet spins more slowly. "700 million years after the planet's birth, life-giving water covers its surface. But not just water. There's something down there. Tiny islands. They seem to have appeared from nowhere. Until molten rock bursts through the Earth's crust and rises up through the ocean. Over time, the lava cools and forms a volcanic island. This is how these islands formed. In the future, they will join together to form the first continents. Our planet has been forged in fire and shaped by violence. But out of this hell comes water and land. And with them, the first clues to why our planet is so special. Why the Earth is home to life. Meteors. They've been raining down since the planet's formation. But now, 3.8 billion years ago, the assault is intensifying. They already brought water to the planet, but they're carrying something else too. The seeds of life itself. Look, the meteorites are dissolving. They're transporting carbon and primitive proteins, amino acids, from outer space to the bottom of the ocean. It's dark. The sun's rays can't reach beyond 300 meters, and it's close to freezing. Wait, this must be a mirage. A city of underwater smokestacks. It's not smoke. It's some kind of hot liquid. Seawater must have seeped down into the Earth through cracks in the crust, getting hotter, collecting minerals and gases on the way. It's this potent mixture that's spewing back out into the ocean, building these towers. Add to this all those minerals and chemicals from the meteorites, and all around us, the water is becoming a chemical soup. It's full of microscopic organisms, feeding on this soupy water. These single-celled bacteria are the earliest forms of life on Earth. We're witnessing a defining moment in the making of the planet. Life is underway. But then, for hundreds of millions of years, nothing changes. There's no progress, no evolutionary steps forward, just single-celled bacteria. Something, somewhere, has to take a giant leap forwards. We're traveling over a shallow ocean, 3.5 billion years ago. Are these rocks or plants? They seem to be growing out of the seabed, like a forest of stunted trees. Each one is a mountain of living bacteria, a colony called a stromatolite. As if by magic, these bacteria are turning sunlight into food. This process, called photosynthesis, uses the power of sunlight to transform carbon dioxide and water into glucose, a simple form of sugar. This is the first sugar ever created, and pretty much the same stuff we put in our coffee. And this magical transformation releases a byproduct, a gas called oxygen. Underwater, the stromatolites are slowly filling the oceans with oxygen. And look, it's turning traces of iron in the water into rust. This is falling to the ocean floor, forming deposits of iron-rich rock. One day, we'll use these to build bridges, ships, skyscrapers. But right now, above the waves, the oxygen is transforming the atmosphere. These stromatolites are creating the single most important element for life on Earth. Without them, virtually every living thing wouldn't exist. When we take our next breath, we're doing it thanks to these colonies of ancient bacteria. Over the next 2 billion years, oxygen levels continue to rise. And as the planet's spin slows, the days get longer. Now they last at least 16 hours. We're discovering it takes a long time to make a planet. 1.5 billion years ago, 3 billion years after the planet's birth, and there's no complex life, no plants, no dinosaurs, no humans. But the Earth has something that no other planet has, a force with the power to change everything. Our planet, a beautiful blue ball dotted with volcanic islands, home to primitive life. But 1.5 billion years ago, changes are underway that will push life on Earth to the point of no return. Over millions of years, we can see something is rearranging the islands. Hidden beneath the ocean, the Earth's crust has broken into vast plates. Deeper still, the Earth's core is at work. It's hotter than the surface of the sun, so hot it generates movement in the rock beneath the crust. These movements push and pull the plates around the globe and carry the oceans and the islands with them. Millions of years race by, Seeing it like this, our planet seems active, changing, alive. Over 400 million years, a vast new supercontinent takes shape, called Rodinia. In the shallow waters around Rodinia, stromatolites have been working their magic here for billions of years, pumping oxygen into the atmosphere. The temperature is 30 degrees Celsius, and the days are now 18 hours long. The pieces are in place for advanced life to emerge. But this looks more like Mars than Earth. To find life here, we need to move on through time. Hold on. Stop. The great supercontinent is breaking up. We're flying over Washington State 750 million years ago. Some force from deep inside the planet itself is ripping the crust to pieces. It's as though the world is tearing apart. And there's only one force powerful enough to do this: heat. It's escaping from the Earth's molten core, stretching and weakening the crust. Centimeter by centimeter, year by year, the great supercontinent is splitting in two. The intense geological activity has spawned a mass of volcanoes. They're pumping carbon dioxide into the atmosphere. There's smoke and gas everywhere. All that carbon dioxide is mixing with water to make acid rain. The rocks absorb the acid rain, including its carbon dioxide. And there are a lot of rocks on Earth right now, exposed when the continent tore apart. So many that vast quantities of carbon dioxide are absorbed out of the atmosphere and locked up in the Earth's rocks. With little carbon dioxide in the atmosphere, there's nothing to trap the sun's heat around the planet. In just a few thousand years, the temperature plummets to around minus 50 degrees Celsius. This frozen wasteland is southern Australia, 650 million years ago. A vast wall of ice is forming, thousands of meters high. The ice is unstoppable. The more ice there is, the more sunlight it reflects away from the planet, and the faster the ice spreads. And there's a second ice sheet, just as high. The two sheets are heading towards each other at the equator. close. But even up here, there's no escaping the ice. Now, an ice sheet up to 3 kilometers thick entombs the entire planet. First, the planet was a molten ball of fire. Now it's a frozen ball of ice. Virtually all the sun's light and warmth reflects back into space. It seems nothing, not even the sun, can rescue our planet now. The Earth is a vast frozen snowball. 635 million years ago, ice has entombed the planet for 15 million years. But it can't last forever. Something must release the Earth from this frozen prison. And when it does, who knows whether life will have survived beneath the ice? Volcanoes have been erupting and breaking through the ice since the world began to freeze. But until now, even their heat and power has made no impact on the ice. Volcanoes pump out billions of tons of carbon dioxide. Before the Big Freeze, the Earth's rocks absorbed most of the CO2. But now, with the rocks smothered in ice, there's nothing to absorb the gas. So instead, it fills the atmosphere. Like a blanket, it traps the sun's warmth around the planet. Temperatures rise, until now, after 15 million years, the ice begins to melt. When the planet was frozen, the ice pushed the crust down. Now, as it melts, the crust is bouncing up, creating fissures and weak spots, and more volcanoes. These volcanoes are releasing more carbon dioxide and pushing the temperature up even further. The melt is gathering momentum. Through a series of chemical reactions, the ice has created oxygen. While the planet was frozen, the sun's ultraviolet rays reacted with water molecules in the ice to produce a chemical rich in oxygen, hydrogen peroxide, the same chemical that bleaches hair. Now, as the ice melts, the hydrogen peroxide is breaking down and releasing massive amounts of oxygen. After a 15 million year sleep, the Earth is waking up, a very different place. Now, 600 million years ago, the atmosphere is warmer. It feels like a summer day. And the days are about 22 hours long. Add all this water, and it's the perfect recipe for life. Before the planet froze, primitive bacteria had emerged in the oceans. But surely they couldn't have survived an ice age 75 times longer than the entire span of human history. If something has found a way to survive, then our best chance of finding it is where we last saw life: in the ocean. Now, 540 million years ago, in an ocean full of oxygen, those primitive bacteria have evolved. A handful must have clung on through the big freeze. Now there are plants everywhere. And something else. It looks like some kind of armored slug. They're called Wiwaxia. They're one of a new generation of complex, multi-celled organisms. The increased oxygen levels are enabling creatures to grow larger and develop bony skeletons. There are worms, sponges, and these. They're trilobites, distant relatives of insects, lobsters, even scorpions. Life in the oceans is blossoming. From microscopic bacteria to a monster like this. This is Anomalocaris. It's about 60 centimeters long. Look at its large eyes, its razor-sharp teeth and grasping limbs. All Anomalocaris has to do is take its pick. The trilobite can't right itself. Its soft belly is exposed. These are Picaia. They're just a couple of centimeters long, but they've got what may be the first ever spine. Over millions of years, this simple structure will evolve into the spine that keeps us standing up. We dived into the ocean, expecting to find life in ruins. Instead, we've entered a world full of life, where trilobites scavenge and monsters prowl. And creatures are beginning to take on familiar forms. If the oceans are swimming with life, what's happening on land? There must be unimaginable wonders, strange creatures, incredible plants, waiting to be discovered. We're looking for life on land. 460 million years ago, and the plates have moved again. Below lies a new continent, Gondwana. It's a warm 30 degrees Celsius. Oxygen levels are close to those in which we live. The land should be covered with plants, crawling with creatures. But there's not much here, beside a few patches of algae. There's only one explanation: the sun. It blasts the surface with deadly radiation. The complex life we've seen in the ocean wouldn't stand a chance on land. But 50 kilometers up, where the rays enter the Earth's atmosphere, something strange is happening. When oxygen meets the sun's radiation, the oxygen is turning into another kind of gas, called ozone. This is forming a blanket around the planet. This ozone layer is absorbing the sun's lethal radiation. Over 120 million years, it's getting thicker, stopping more and more radiation from reaching the Earth's surface. Without the ozone layer, life on land simply wouldn't exist. Now, shielded from radiation, conditions are perfect for life to take hold on land. Look there. Those small mossy lumps are our first land plants. And they're pumping out even more oxygen. Levels are rocketing. $375 million years ago. One day, scientists will make a remarkable discovery here in what will be a remote valley on Canada's Ellesmere Island. They will discover the fossilized remains of this strange fish, called a tiktaalik. Its neck is mobile, allowing it to raise itself up. It's using its fins to support itself, as if they're legs. Move out of the water. Over 15 million years, these creatures, called tetrapods, evolve. They grow stronger limbs and spend more time out of the water. Until 360 million years ago, they make the land their home. It's from a creature like this that all four-legged vertebrates will evolve. Dinosaurs, birds, mammals, and eventually, you and me. Everywhere we look, there are mosses and ferns, some at least 30 meters tall. It's a seed, the first we've seen. Until now, plants reproduced using spores, single-celled particles that need plenty of water to survive and grow. But this seed is kilometers from water and flying even further inland. To survive, this embryonic plant must have its own onboard food and water supply. So unlike a spore, this seed can survive far from water for months, even years. Our tiny seed is now a mighty tree-like plant, one of a vast forest stretching far inland. The humble seed is spreading life across the planet. And all these trees and plants are pumping out even more oxygen. We could stand here and take a breath. We could live here, right now. We've come a long way, from a lump of burning rock and dust to a blue-green ball bursting with life. But humans won't walk across this landscape for another 360 million years. What was that? It's a dragonfly. A dragonfly the size of an eagle. This giant is called Meganeura. What were once legs have evolved into wings, extending the dragonfly's hunting territory over a vast area. There are millipedes, cockroaches, spiders, all sorts of bugs down there. These creatures, called arthropods, were among the very first to set foot on land. They've been around for hundreds of millions of years already. They look almost identical to the bugs that invade our homes, except for one big difference. Like Meganeura, they're monsters. 360 million years ago, we've stumbled into a lost world of giants, where millipedes are 2 meters long and scorpions the size of wolves. All the oxygen in the atmosphere allows their respiratory systems to be more efficient, freeing up space for their bodies to grow. And over there, a lizard-like creature called Hylonomus. The creatures we've seen so far laid their eggs in the water. But these eggs contain all the water and nutrients the developing Hylonomus needs. The babies are growing in their own self-contained pond. The egg is a major evolutionary breakthrough. Now animals can leave the water behind and conquer the land. This baby Hylonomus will lead the advance. It's a new kind of creature, a reptile. Inevitably, with life comes death. There's so much dead plant matter, it builds up and decays into dense, soggy layers. Over hundreds of millions of years, rocks will cover these layers. Heat from the Earth's core and pressure from the overlying rocks will transform the layers of dead plants into seams of coal. Each lump of coal we burn today to warm our homes and fire our power stations is made of plants that died 300 million years ago. Amidst the decay, hidden from sight, life is stirring. Soon, seeds will germinate, plants will grow, and this wasteland will live again. Life seems to have conquered the planet. $250 million years ago, a herd of creatures grazed the Siberian plains. They're not dinosaurs. They won't set foot on the Earth for at least another 20 million years. But they are big. Evolution has taken a huge leap forwards. The small lizards we saw earlier are now giant reptiles. These are scutosaurs, the distant relatives of turtles. They're plant eaters. And if the plant eaters look this tough, the carnivores must be seriously mean. It's a Gorgonopsid, the largest killer on the planet right now. We're meters away from a perfectly engineered prehistoric killing machine. Its saber teeth have wounded the scutosaur. It's watching as its prey grows weak from blood loss. Backing off. Something strange is happening. The ground is getting hot. There must be enormous pressure beneath the surface. There's lava, but this isn't one single volcano. The entire landscape is erupting. A massive plume of mantle is rising up from deep inside the Earth, pushing molten rock out through fissures in the Earth's crust. The lush paradise is becoming a lifeless hell. On the other side of the continent, it's as if nothing happened. Snow. But the temperature is about 20 degrees Celsius. It's not snow. It's ash. fallout from the eruptions some 16,000 kilometers away. This ash is burning, suffocating, and the animals are dying. 250 million years ago, the largest mass extinction of all time is underway. The atmosphere is full of sulfur dioxide from the eruptions. As it rains, the gas is turning to sulfuric acid, burning everything it falls on. At first, it seemed like this was a local disaster. Now it's gone global. All that volcanic activity is pushing up carbon dioxide levels. The atmosphere is getting hotter. Water evaporates. Vegetation is dying. We thought life had finally found a foothold. Now it looks like we were wrong. There's nowhere left to hide on land. Life is running out of options. This can't be right. The oceans are turning pink. And the plants, the trilobites, the predators, everything's gone. Everything except for this pink algae. The new, hotter atmosphere must have heated the oceans and stripped them of oxygen. Now, nothing can survive in the stagnant water except algae. The Siberian eruptions are transforming the entire planet. Nothing, not even the deepest ocean floor, is beyond their reach. If the sea is heating up, there could be another problem. Look, there, bubbles. They're escaping from vast pockets of methane gas beneath the seabed. Methane is a greenhouse gas, at least 20 times deadlier than carbon dioxide. Until now, the gas has been frozen. Now, with the sea temperature rising, it's beginning to melt. It's seeping up through the seabed, bubbling up through the water, and escaping into the atmosphere. This powerful gas is pushing up temperatures even further. Up to 40 degrees Celsius, 6 degrees hotter than before the Siberian eruptions. Now, even the creatures that have made it this far are doomed. It's 500,000 years since the eruptions first began. And all this time, for 500,000 years, the lava has been pouring out. By now, it covers an area the size of the United States with a layer of molten rock nearly 6 kilometers deep. "95% of all life has been wiped out. Only a handful of creatures have survived so far, by burrowing underground and eating anything. The mass extinction has reset the evolutionary clock. 250 million years ago, we're back where we started, on a lifeless planet. Almost. It's 50 million years since virtually all life on Earth was wiped out. And the planet has been transformed. It's now 200 million years ago. And there's just one supercontinent, called Pangaea, stretching from pole to pole. After the trauma of the mass extinction, the planet is healing. Temperatures are stabilizing, the acid rain is neutralizing, and vegetation returning. And with 95% of all life on Earth wiped out, the field is open for a new species to emerge. One that will dominate the planet like no other before or since. The dinosaurs. These dinosaurs are called amosaurs. Like all dinosaurs, they've evolved from the handful of reptiles that survived the mass extinction. At 4.5 meters tall, their size makes them slow and vulnerable. A Dilophosaurus. 2 of them. They're small and fast. The Amosaurus is too big a meal for one Dilophosaurus, but not for 2. The dinosaurs have conquered the Earth, but no species can tame this restless, volatile planet. The Earth's crust is thinning here. It's releasing lava, shaking with earthquakes, as though it's being stretched by some unseen force. And the same thing is happening all the way down what will be North America's eastern seaboard. The Earth's plates are on the move again. 190 million years ago, the great supercontinent of Pangaea is breaking up. A vast chunk of land has broken away and formed a new ocean called the Tethys over what will one day be the Middle East. Currents are pushing nutrients up into the coastal waters. And the nutrients attract fish in their millions. And with so much life comes death. Dead fish and plankton carpet the ocean floor. Over the next 10 million years, layers of rock will bury and heat the dead creatures. Ancient fish and plankton will become oil. Every liter of gas in our cars, every piece of plastic on the planet, the paint on our walls, the carpet under our feet, even the soap we wash with, all originated this way. 180 million years ago. And further west, the North American plate is still moving away from the European and Asian plate. It's happening slowly, at about 2.5 centimeters each year, the same speed as our fingernails grow. But hit fast forward, and we can see a new ocean forming right beneath us, and new continents. Montreal is moving away from Marrakesh, New York from West Africa. The world, as we know it, is taking shape. The chasm between the two continents fills to create a vast ocean, the Atlantic. And there in the middle, a volcano. We've seen plates move before. We know it's caused by currents deep beneath the Earth's crust. This process is happening down there right now. The entire sea floor has been torn in two and pushed up into a ridge of mountains and volcanoes. It's growing higher than the Himalayas and longer than the Rockies. The water's hot here. Molten lava is forcing its way out from deep inside the Earth. As the lava cools, it creates volcanic mountains and new ocean floor. Over millions of years, this process pushes the plates and Pangaea apart and rearranges our world. It's this geological activity that makes the Earth restless, creative, unique. And every time the planet reinvents itself, the things that live on it must adapt and evolve. Things like these. They're ichthyosaurs. Their reptile ancestors lived on land, but as the planet changed, so did they. They grew fins and moved into the newly formed Atlantic Ocean. This one is 6 meters long and fast. It travels at about 40 kilometers an hour. It's the ocean's fastest creature, the most efficient predator, and it's ruled the Earth's oceans for 50 million years. But now there's a new contender for the crown. Pliosaur. Longer than a bus, as heavy as a truck. Its jaws are immense, 8 times more powerful than a great white shark's. And its teeth at least 30 centimeters long. The Earth, and the creatures that live on it, has changed beyond recognition. This was once solid ground. Now it's the Atlantic Ocean. It was on this very spot that we stood and watched Amosaurs graze and Dilophosaurs stalk their prey. The dinosaurs' world may be different, but they're as dominant as ever. They appear invincible. "65 million years ago. They're one of the planet's most successful species. They've survived volcanic eruptions, earthquakes, entire continents splitting in two. The dinosaurs have thrived for 165 million years, but nothing is invincible. It's a mammal, and it's evolved from the small number of mammals that survived the mass extinction 185 million years ago. It's also prey for the dinosaurs. This is why most mammals live in the trees or underground and venture out at night. Mammals are no threat to the dinosaurs. Nothing can challenge their dominance. Nothing on Earth. It's a lump of space rock, a large one. This asteroid is about 10 kilometers across. Bigger than Mount Everest. It's heading for the Gulf of Mexico, just off the Yucatan Peninsula. Everything's happening so fast. Blink and we'd miss the impact, unless we slow down time. It's a split second that will change the world forever. Even now, at the moment of impact, the asteroid's back edge is still up here at nearly 11,000 meters, the same height as a commercial aircraft flies. The asteroid strikes with such immense force, it destroys everything it hits. Even the asteroid itself instantly vaporizes. The impact is unleashing the energy of millions of nuclear weapons. Nowhere is safe, not even up here. Some of these boulders are as big as entire city blocks. It's the blast wave, racing out from the impact zone like shrapnel from an exploding bomb. Minutes after impact, thousands of kilometers from where the asteroid struck, the Earth is under attack from every direction. Boulders are raining down. Earthquakes shaking the ground. And tsunamis battering the coasts. But the onslaught has only just begun. The plume of molten rock and dust is spreading out and engulfing the planet. The entire sky is acting like a giant sun lamp. The Earth's surface is now 275 degrees Celsius. Vegetation is spontaneously igniting. Even months after the impact, smoke and ash are still blocking out the sun. With no sunlight, plants are dying, and the animals that eat them are starving. Against this onslaught, it's hard to see how anything could survive. "65 million years ago, the dinosaurs have been blasted, stoned, and burnt alive. The dinosaurs' 165 million year reign is over. But the dinosaur's demise is an opportunity for another species. Mammals. By living underground, they've avoided the heat and the fires. And by eating anything and everything, they're thriving while more selective eaters are dying. These are the unlikely inheritors of the dinosaur's crown. And as one story ends, another begins. Could this be our chance? Our time? Will the next chapter belong to us? The dinosaurs are long dead. The planet is peaceful. In this new world, our mammal ancestors are evolving. This lake, 47 million years ago, in what will one day be Germany, should be the perfect place to spot them. This isn't like the mammals we saw earlier. Its eyes and brain are bigger. This is Darwinius massilae, or Ida. She looks nothing like us, but fossil evidence from our own time tells us these creatures could evolve into monkeys, apes, and eventually humans. We're looking back through 47 million years of evolution to what may be one of our earliest known ancestors. The lake sits on a volcanic crater. It's belching out noxious gas. Now, the lake that killed her will preserve her in its oxygen-depleted depths. One day, when the water has gone and Ida is fossilized in stone, we, her descendants, will discover her and recognize in this primitive primate what could be the very beginnings of our own story, the story of human life. We're closer to understanding how everything we've seen, from ocean bacteria through walking fish and subterranean rodents, leads to us. And to understanding how our planet was made. "47 million years ago, and the atmosphere is much like our own. The temperature is 24 degrees Celsius. And a day lasts just under 24 hours. The Earth we're looking at now is almost identical to the planet we call home. Almost. The Earth's plates are moving again, carrying the continents on their backs. This time, India is moving north towards Asia. The Indian and Asian plates are locked in a titanic struggle. Neither plate is winning. Both plates are beginning to buckle. What was once ocean floor is contorting upwards along a 2,400-kilometer crumple zone. A vast mountain range rises up. 1,500 meters. 4,500 meters. Now over 8,000 meters. These are the Himalayas. And there it is, the highest mountain of all. Mount Everest. Its summit reaches up into the Earth's jet stream, at the same altitude as airliners fly. When the snow on the peaks melts, it feeds great rivers. The Ganges, Indus, Yangtze, and Yellow rivers. The Himalayas are like a vast water tower. One day, their rivers will supply water for almost half the world's population. "20 million years ago, this is our planet. With every continent, every ocean, just as we know it. Except there's one thing missing: us. the human race. For humans to evolve, something, somewhere down there, has to change. Along Africa's east coast, between the plates that make up the Earth's crust, a great rift is opening up, 4 million years ago. The rift stretches nearly 6,000 kilometers. Along its edge, mountains are growing. Stop. There. It looks like an ape, not a human. They might stay in these trees forever, but their world is changing. The growing mountains must be acting like a wall of rock, stopping moisture from the Indian Ocean passing over the land. It's getting hotter and drier. The lush rainforest is becoming arid savanna. The new, hotter climate is destroying the creatures' habitat. It's forcing them to search further afield for food, to stop dragging their knuckles on the ground like apes, to stand up and walk on 2 feet. It's the most important step in the human story. This mountain range along Africa's east coast could be the reason we walk on 2 feet. It seems incredible. The random movement of 2 plates may have kick-started a chain of events that will lead to the first humans. A man and child. It could be a scene from our own time. But it's 1.5 million years ago. These are an early species of human called Homo erectus. And these are the first ever footprints like our own. Our journey is nearly complete. But our ancestors still have to make their own journey out of Africa. The climate is changing again. 70,000 years ago, sea levels are falling. The gap between Africa and Arabia is shrinking, down to just 13 kilometers. The Red Sea is narrow enough and shallow enough for this small group to cross out of Africa. They're another, later species of human, called Homo sapiens. They've made it across. Scientists believe every man, woman, and child outside of Africa is descended from these 200 or so individuals. Over time, our ancestors multiply and spread out to India, onto Asia, and into Europe. But while humans head north, a giant wall of ice is spreading south. It looks like, once again, our planet and the things that live on it are about to go head to head. Europe, 40,000 years ago. Our Homo sapiens ancestors are arriving, only to find a world that's changing fast. It's getting colder. It should be the height of summer. But the plants are frostbitten, the rivers are frozen. Natural changes in the Earth's orbit, CO2 levels, and the flow of warm water around the planet are conspiring to lower the Earth's temperature. The Earth and its inhabitants is entering an ice age. Just look at these. Glaciers as high as skyscrapers. They're creeping over the northern hemisphere at 30 centimeters a day. Slow and powerful, they sculpt the landscape as they move over it, gouging out great depressions. The planet will never look the same again. Now, around 20,000 years ago, they're grinding to a halt. Much of the northern hemisphere is covered by ice sheets up to 2.5 kilometers thick. With trillions of liters of water locked up as ice, sea levels have fallen. "20,000 years ago, a strip of land has emerged from the ocean between Siberia and Alaska. It's a bridge between two vast continents. A gateway taking humans from Asia to a new world, America. It's the last great continent to be colonized, the last great human migration, and somewhere down there are the first Americans. Now, 14,000 years ago, the changes that triggered the Ice Age must be going into reverse. As the ice retreats, it's revealing a very different northern hemisphere. The glaciers gouged out huge depressions. Now they're filling with water to become North America's Great Lakes. "6,000 years ago, the ice retreats back to the poles. After a 4.5 billion year journey, we've made it. We're back home. This is our world, our time. Now, for the first time, we can piece together our planet's incredible story. We can understand how and why everything we see around us is here today. From the skies above us, to water, the essential ingredient for life. The ground beneath our feet. And life, the spectacular result of a random chain of catastrophes and coincidences. Each triumph, each disaster is a step on the trail that leads to here, to each and every one of us, right now. But Earth's story doesn't end here. A lot has happened, but there's more to come. The Earth will live for at least another 4.5 billion years. everything we've seen on our journey is only half the story. Just imagine what wonders, what terrors, what strange creatures lie ahead for our restless, creative planet. The next chapter of Earth's story is still to be written.